about your ELSI specifically because in the context of iGEM, we also have the same kind of judgment, but the name is not specifically ELSI, but it is named as human practices.
Oh, I see. Okay.
Yeah, maybe a different context, but the same fundamental, I guess.
Mm-hmm.
And maybe after you share what you done with your biomod teams, maybe we could also share our projects, what we are working on, and maybe have your judge to our project.
Okay. Yeah, sounds good. So yeah, if you don't remember, our project from Biomod was targeting Alzheimer's disease. And essentially, like early detection for Alzheimer's is really difficult because Alzheimer's or people with Alzheimer's can show a lot of different symptoms. And so usually it's not detected until very late because they have to go through a lot of testing before like a conclusion can be reached. And so the whole point of our project was to kind of introduce like a device that people can use early on, just during regular checkups or regular like clinical check-ins. And so essentially what it is to detect certain biomarkers or proteins that are found in the blood um, for people with Alzheimer's disease. Like it's found in higher concentrations, higher accumulations, um, just because of like different, I guess, alterations in the brain that happens when you begin to develop like dementia, and or like other neurodegenerative diseases. And so the form of the device was it was called a lateral flow assay or an LFA. And so if you've ever seen like a rapid COVID test or a pregnancy test, essentially like on a pregnancy test, you use urine like from the patient's sample, and it'll show like lines if the person is pregnant or not because there's certain biomarkers in the urine that trigger those lines. And so we decided on that because it's really portable. It's relatively low cost. It's something that's relatively non-invasive. Like blood work is pretty routine for people who are already getting checkups. You don't have to go through any extra testing. And I think what we really emphasized was that it's not meant to be a final diagnosis. It's more so, okay, if this does show, increase in biomarkers, then the person can, you know, go undergo more clinical testing and, just be under more supervision in case they have or showing signs of Alzheimer's. So I guess in the terms of ELSI, I think what was really important for us to emphasize was, first of all, the regulatory considerations. And so, like, because we're from Canada, we did a lot of research, like in terms of Health Canada and their guidelines. And so I know you guys are from Indonesia, so obviously it would be specific to your country and your like whatever, I guess, guidelines they have. And also thinking about just like the overall impact on the public, like how do I word this? Thinking about the perspective of the patient, and their everyday life, thinking about like what they want in terms of clinical testing. Not everyone wants to undergo like a lot of complex, expensive testing, because healthcare can be really expensive. And so I think also emphasizing like economics is really important. But that's basically like the summary of it. If you have any other questions about that.
All right. I think our project have a lot of similarity because we also working on biosensors that acts like point of care testing, which is yes, which is really similar like what you did. You can use it anywhere. It is also affordable. But
Awesome.
I think we have a different target. But I will present to you later. But talking about the outside that you do, I think we want to know what action like you did on the biomod competition. Like,
Mhm.
did you interview many medical practitioner, or did you interview the patients, or like what action did you really you did really do?
Yeah. Um, we did interview a few people, mainly like faculty from our university who did like work a bit closely with patients with Alzheimer's. Um, I would say we didn't interview as many people as we would have liked to, just because obviously we had time limits, but it's really good that you guys are interviewing people. Um, I think it's just a really great way to gain perspectives and yeah, just like interview a wide range of people. So like patients, healthcare workers, doctors, like researchers in the field, whoever you think would be helpful. I think everyone has a different perspective, and I think it would be really helpful. We did like aside from interviewing people, we did a lot of review on literature. I think that's also really helpful. Like seeing what's already out there just to inform kind of like what your goal is. So I think and then like the faculty that we were working with, like the professors and the supervisors who were overseeing our project, they were able to kind of give us like a lot of helpful papers to kind of learn more about the field that we were targeting. So yeah, I think interviewing a lot of people is a great way to gain perspectives and also yeah, reviewing papers, which I'm sure you guys are already doing, just to learn more about like what you're researching.
Okay, maybe other than that, did you do maybe like, because what I saw from other IGEM team, or maybe any synthetic biology competition, they like to do like a workshop. Maybe they do like a social activities where they come to, maybe if the context is about Alzheimer, maybe for instance they come to Alzheimer community around their neighborhood, sort of like that. Did you do something like that, during your competition, for showing that you really did the impact of the LSI? Or
Mhm,
LSI is not something like that?
mhm. Honestly, I don't remember if we did. I wanna say we didn't.
Mm,
Um, yeah, I think a lot of our like, what we talked about in ELSI was really just informed by, like, the interviews that we had, and talking about it from, like, a user's perspective, and I think that's really important to emphasize. Yeah, just, like, gaining like, especially people who have done research projects in the past and have, like, done, like, ethics applications because it can get really complicated. I think it's really important to talk to those people, and I think that's what we did. Um, yeah, I mean, because ethics is a very, like, complicated and very, like there's a lot of perspectives that can go into it. So, I think trying to find those people who specifically have worked with, like, ethics in the past is really, really important. But I don't think we really did, like, much outside in the community for that.
mm,
Mhm.
I see.
Yeah.
All right. And I think, did you have like sort of like any guidelines for the interview session that you did? Maybe like you have to ask about certain things that implies to your LSI. Maybe you
Mhm.
have to ask this, that. Do you have
Mhm.
any guidelines?
Yeah, I think if you're interviewing people who are like experts in the field, I think it's okay to kind of just like jump right into it. But let's say you're interviewing, well, I'm not sure like what problem you guys are addressing, but let's
Okay.
say like for example, it's like an Alzheimer's patient
Mm,
or like a care or like a family member who has like taken care of an Alzheimer's patient, they may not necessarily know all of the technical aspects of like design and everything. So I think what's really important is to try to introduce it to them in a way that they can understand it. Um, and also just leaving questions like open-ended
Mm.
is really important too, just so that they can kind of give you like perspectives from like all over, like not even just like input on the design, but also just like the experience of having to take care of someone with Alzheimer's and what this like device can and like how it can help them, if that makes sense.
All right.
Yeah.
And did you really test your product for the Alzheimer patients?
No, we did not get that
Is
far.
it, is it like a proof of
It was
concept, right?
all just a concept. We honestly we didn't get far in the wet lab at all.
Yes.
I know this year's biomod team is doing a lot better than we were, so it might have seemed like we knew what we were doing, but honestly, like it was kind of a mess leading up to the
Yeah.
competition. I felt very unorganized, but I mean we made it, so that's all that matters.
But I think all of the teams in synthetic biology competition is always like that, right? Like we don't
Yeah.
really have that period of time that we can pass it into real patient.
Mhm.
Okay, maybe I'll present to you what the team have been working on, and maybe
Sure.
you can share your view.
Yeah, I
Or
would love that.
yeah, yeah. Wait, let me share my screen for a second. So yeah. Um, anyway, did you have you ever joined competition like IGEM before, or maybe your campus have one?
We do have like an iGEM
Hmm?
team on our campus, but I've never joined it. Only biomod.
Hmm. But um, do your campus join it this year?
I think so. I'm not sure. I'm
All right,
not really updated with what they do.
all right, all right. So this is why I said that we do have a similar project.
Mhm,
So for a quick general view, um, this year's our team we have also in the medical problem, which is specifically in liver problem.
mhm,
But what I want to highlight is it could be applied to any disease,
mhm,
because what we're highlighting is we want to create a diagnostic tool
mhm,
to know certain bacteria in gut's microbiome in the patient's gut that can be a biomarker for others organ status. For example, in this scenario, if the patient has the liver disease, which is MASLD, the patient's gut microbiome will have a certain profile, a certain spike on a specific bacteria that can be a biomarker that the patient's liver is not good, sort
mhm,
of like that. And we want to create a point of care testing, sort of. The end goal is something like you said earlier, but not in a strip, not in a stripe, not in stripe things like you said, but we want to create a agglutination based assay. So if a positive, if the sample is positive, then the agglutination is done. But if not, there's no agglutination, sort of like that. But the idea is to create a rapid, low cost, and accessible biosensors. So starting from that point, we sort of search. we research, doing a literature review, what can be done to create that kind of biosensors, and also integrating the synthetic biology because that's the main idea from the first place.
Mhm.
So our idea was to create a bacteria that express nanobody, which is a smaller version of antibody, because our hypothesis was if we can create a nanobody which is smaller, it can express better and mitigate the risk of misfolding. And why we want to express it on the surface, because we want to create a agglutination based assay where the bacteria can agglutinate other bacteria that has a specific surface protein. So we target a specific surface protein that responsible to certain disease in human guts microbiome, and hope that we can create a agglutination based assay. So if the agglutination is done, then the result is positive. If there is no agglutination, then the protein surface of our bacterial targets is not there, then it means negative. And what we're doing to achieve that is we create the project into into two department, which is dry lab and also the wet lab. In here, the dry lab focus on two main projects. First is to know what is the biomarker candidate. In this case, is the muscle D, which is the disease that we are working on. And on the stage one, the dry lab is searching for that biomarker candidate based on metagenomics data. So they're searching for any reads there are anomaly. And the stage two is to create a nanobody, as I said earlier. This nanobody based on the de novo design, which is kind of a field that are currently emerging right now, how to design any antibody or protein binder that is de novo, and and then the next step they done is doing the screening test to search for the specific nanobody that has strong affinity. Well, this is the stage one that they've been doing, where we want to know which specific biomarker is responsible for um, any gut microbiome related disease. In this context, is the muscle D. So, and the next step is to design the nanobody. We created a new nanobody based on the novel design, based on the protein surface target that this biomarker research has done before. And the next step is the wet lab is uh, validate those process by expressing it in the real cell, in the bacterial cells, and see whether it is the agglutination is real or not. So that's basically the general view of our project. I think on the concept of creating accessible biosensors, I think we have a similar project, but the difference is our target is not on the analytes like you did, I think, but
Mhm.
more on the bacterial. So we sort of create a bacter sensors, if there is a correct name for it. And I think what we want to know also, other than the technical stuff here,
Mhm.
if you want to dig deeper into that, like you can criticize, like maybe you got it wrong or something like that. But what we want to hear as well is, do you have like any tips like how to design this project
Mm.
to really target those in needs? Because I think that's the most important thing, right? for the human practice, or you might call it ELSI judgment, right?
Mm-hmm.
Yeah, I think that is all about our project. Just a quick general view. Maybe you have something to say.
Yeah, I think that's really cool. I love your guys' project, and I think that's pretty feasible. I would just say, I guess just like from like my perspective, just like be careful by saying like, oh, we think this could, be applied to a bunch of different diseases, because I think
Yeah.
um like every condition is different, and so it might be different for those. But I mean, aside from that, you guys have like a specific problem that you're addressing, and I think that's the most important thing. Um, I guess I just want to know more about how this is gonna be like integrated into like clinical testing. Is this for like the laboratory like analysis, or like when is this kind of
All right.
implemented?
Well, yeah, I think we also, um, similar to your project, we also don't test it directly into patients' fecal sample, but
Okay.
um, what we want to prove here is still just a proof of concept.
Mm-hmm, mm-hmm.
And that's also what we are confused right now, because um, if we want to say that we want to detect bacterial profile in the muscle disease, we sort of have to really detect those bacteria, right? But our confusion right now is whether we can say our project is really related to muscle D or not, because what we plan here is we want to test it first as a proof of concept whether it can bind directly into other bacteria or not, but not a bacterial that's specific to methyl D.
Mm.
But what we fear here is it will be a minus point for judges, because we don't really test it into the methyl D specific bacteria, sort of like that.
Oh, I see. Okay.
Yeah.
And then I'm just looking at the okay.
Hmm.
Yeah, yeah, that makes sense. And I think um like from a human perspective, I
Mhm.
think like the visual detection is really good. I am just a little worried because it could
Mm.
be kind of ambiguous. Like sometimes, like at least for our project, like I'm just trying to think like because like a line is like pretty obvious in terms of like detection, but like is there like a range of like visual detection for like what happens when the bacteria bonds?
You mean like the visual here, the readout?
Yeah, yeah.
Well, for now, based on the literature we've read, I think there's no range, because yeah, there is a range, but it needs further research to
Right.
know at a certain range. We further research to know what certain range means, what certain maybe in other unit like CFU, or maybe other
Mm-hmm.
unit that can be a representative unit.
Mm-hmm.
Yeah.
Yeah. Okay, that makes sense. I think what's really important, like for LSI, is just like making sure, like if this were to be integrated into like a lab where like clinicians and like healthcare
Mm.
workers have to analyze the results, that they're like aware of what everything means. Just because it can get like really like it can get complicated, and you know, I guess what's really important is emphasizing like, is the project design going to make diagnosis simpler, or is it going to make it
Mm.
more complicated? Um, so I think that's just something to consider, but I really like the concept behind your guys' projects.
But on your project, did you like did you plan like, okay, this project is gonna be implied in real society at this year, like sort of like a map, a timeline map. So you really like plan our project will be like this in this year, and then will be like this in the next year, and the next year like that. Did you make
Uh,
like something like that? Like it will
Similar,
pass
yeah.
the
I think
clinical test, maybe.
yeah, I think we did something kind of similar. Like obviously it wasn't super specific, but I think we also discussed like potential work in the future. Um, like obviously it wasn't like month by month because it's
Mm.
hard to say, right? But we gave like a general estimate of how long we think it would take to like be approved by like like the government, like the
Yeah,
regulatory departments and things like that. I mean, our project kind of like stopped as soon as we were done with the competition.
yeah,
I think they kind of changed the direction of the project for this year's biomod.
yes.
I have no idea what they're up to because I'm like not part of the team this year. But yeah, that could be something to consider. Just like maybe putting in some time to research like where this could go in the future, how long it could potentially take. Because I think what's really important to consider is how feasible it is to
Mm.
actually be like an approved device. Because let's say it takes like 20 years, then like, stakeholders might be a bit hesitant to
Mhm.
consider your device if it's like something that has to undergo like very complicated and rigorous testing. So yeah, that is something I would consider. It's something that we sort of did. Yeah.
All right. Is it possible if we see what you presented on Biomod, like the LC
Yeah,
segment?
sure. I will have to find it, but let me see. For now, I can probably show you our website, and I can
All right,
also
all
like
right.
send
That would be
you
good.
guys a link, just so you can like refer to it in the future if you'd like. So let me find that.
Or maybe you can present it on
Yeah, I
this.
can present it as well for sure. Okay, let's see here. Let me share my screen. Okay, can you guys see my screen?
Wait. Yep.
Okay. Yeah, so yeah, this is our website, and then after we're done meeting, I can send one of you guys the link. So if you ever
Sure.
want to go back to this in the future, feel free. You're more than welcome to. Um, so it's a pretty brief overview, but essentially, like for the ethical sides, like we talked about, like the respect for the people, and so this is more so like making sure that like during the research that people are kind of aware of the purpose of our device. And so, as I mentioned, it's not like a final diagnosis, it's more so an early diagnostic device, and that it should be used in combination with clinicians and other testing. So, it's not meant to replace consultation with like a licensed clinician. I think that's really important is that since our devices are similar, I think you need to emphasize that it's not meant to be like a final diagnosis. It's meant to be like used as like an indicator, and that further like testing and research can go into it. If that's correct, is that kind of similar for you guys' project?
Yeah, I think so. Like it wouldn't be the gold standard of our this disease diagnostic, right?
Hmm.
Like, yeah.
Yeah. Okay. And then, yeah, we also talked about how respect would be maintained through clear communication with participants, families, if consent is given, medical professionals. And so I think this is a really important thing to consider in any research project. Like, for example, I did a research project last summer, And I talked a lot with patients and nurses, and I think what's really, really important is to make sure that your documentation is like very like understandable and very, very detailed. Because if the patient doesn't understand what the purpose of the research is, they might be hesitant to, I guess, use the device or participate in the research. So ensuring that like communication is clear is also something really important to remember. So yeah, we just talked about that here, like ensured documentation, ongoing consent of participants. And I guess as like a side note, you should also talk about any potential risks, because no project is perfect, right? And so there's always risks associated with research projects. So yeah, I think researching that as well would be really important. If we scroll down here, the social aspects of this, the concern for welfare. Um, won't I'll be completely honest, I don't really know what this means. Again, I wasn't the main person writing about the social aspects. But essentially, like what I can get from this is like ensuring that our device is not contributing to any inequalities. And so we want to make sure that the device is accessible as possible to everyone. Again, since what our research showed for current solutions like MRI scans, like the big scanner machines, they can be really expensive. And so we want to make sure that our device is accessible to a wide range of families and like incomes, if that makes sense. So that's basically that section. The legal section is pretty straightforward. Just like make sure you're not breaking any laws. um, I would just, yeah, I think that's pretty straightforward. I think at least what we wrote about here, when you're doing like research, basically like write about it as if you were doing like a research study, which like, I mean, you we basically are for like these type of competitions. But if you were to kind of recruit like patients for like clinical testing, like make sure that recruitment is fair and that you're not like excluding anyone, because it's really important to gain like information from like a diverse group of people. So that's like basically that. And then this is like biosafety stuff. We kind of did like a risk analysis. As I mentioned before, I think what's really important is to research the potential risks associated with your project. And so what we did was kind of defined kind of potential losses. And obviously, um, it ranges in severity. So misdiagnosis can be a bit like obviously that does have some risk associated with it, but like the loss of life itself is also like that's like the most severe it can get. And so we made like a table with the different risks and then the associated loss, and then just like basically a description of that. um I won't go through this entire table. You guys can I guess go through it later if you want, but is everything kind of making sense so far? Do you have any like further questions?
Yeah, yeah,
Okay.
everything's good.
Yeah. And then we also developed like mitigation strategies for the risks. So not only is researching the risks really important, but you need to develop like feasible and realistic strategies for how you would address the risks if they were to come up. So um yeah, pretty straightforward, like making sure that all your biomaterials are stored properly and disposed properly. Again, really important, the ongoing and documented consent of participants. So just again, really emphasizing that communication with the stakeholders and the users that you're interacting with. The device compliance with Health Canada. That's just our regulatory department. I don't know what it is for Indonesia, but I mean, I'm sure you guys have researched that a little. If not, I highly recommend you just do some research into that. Yeah, and then just like the safety protocols, data sheet recommendations. If I'm sure you guys have protocols for like your wet lab and stuff, so making sure like all those protocols are being followed. Yeah. Let's see, references. I guess we just like put our references in here. Anyways, that's kind of the section on our website. After our meeting today, I can see if we have like more stuff on the LSI, like presentations that we did and things like that. I don't want to like waste your time right now. It'll probably take me a while to find it. But yeah, I'll definitely send that to you guys for future reference.
All right. Thank you. Thank you. Maybe last question from me would be, like on the presentation, did you present the proof that you're really following the biosafety protocols? You really follow the legal and also the ethics? Like, how did you prove that you really done it? You know, like
Yeah.
in the presentation, what did you present like that?
Okay, let
Maybe
me
if you
find.
still remember, but
Yeah, I want to say we did. The the competition was so long ago, I don't really remember it. When I was up there presenting, I kind of like I kind of like blacked out. I kind of like don't remember anything. But let me try to find our presentation. But
it's okay.
um,
And maybe just a
I want
general
to.
view.
Yeah, I want to say we did. And I think it would be really important to at least
Mm,
talk about it briefly. Talk
mm,
about what you did and like
mm,
how for example, like if you're interviewing people, how did that
mm.
influence the development of your project, right?
Yeah,
um
because what I saw from your website is there's a taxon table, right? But did you really like further prove it in your presentation? Like maybe you know having the interview documentation, or maybe
mhm.
yeah, sort of like that.
um I wouldn't say you don't go into like super like details for the
Mm,
presentation, just because the presentation is meant to cover like everything and you
yeah.
do have a time limit, right?
Mm.
So it is hard to be super detailed in the presentation, I think. Does do you have to develop a website for iGEM as well?
Yes,
Okay.
it is one of the deliverables.
Okay. So I think my advice is to keep like the very like small details for the website. Try to keep it a little bit more broad for the presentation, especially because when you're presenting, this is the first time that these judges are, or like the first time that the audience and like some of the judges are like ever seeing your project, right? And so they're trying to understand it for the first time. And so really, going into like the complex details can be confusing for them. And so I think keeping it as like understandable as possible is really important. Um, Let me see if I can find our presentation so I can give you an example.
Okay,
But yeah,
maybe.
does that kind of make sense?
Yeah, of course, makes sense. I think it helps us a lot. Maybe other than me from the human practices department. Do you guys have any questions regarding to outside? Oh yeah. Anyway, I also want to introduce here my friend Ferlin. She is the leader of the team right now from the IGEM Brawijaya. So, and she is also the head of human practices department. So,
Oh, that's amazing. Well, nice to
yes.
meet you.
Nice to meet you too. Okay, so presentation. Sorry, am I audible?
Yeah, I can hear you. Yeah.
Oh, okay. So, what I heard from your presentation is, um, maybe I'm just curious because I want to ask, like, if you could improve like one aspect from your biomed project ELSI before, like, your team is the winning the best ELSI award, but maybe is there anything that you could fix so we can learn from it and then we can try to uh, do it in this IGEM human practice?
Mm-hmm. Yeah. Ooh, that's a good question. It's also a little hard for me to answer because I want to say like the human practices is what we did best. I think everything that we messed up on was like everything else, like the wet lab stuff, and because like I don't know if you remember, like I don't know if you remember this from our presentation, but we like basically like had no results from like our wet lab just because we were just so unorganized. And so I think that's like the one thing that really helped. But I guess like the one thing that maybe we could have worked on was like interviewing more people. I think that would have been like more helpful to include. So again, it's good that you guys are doing this. Yeah, and just like interviewing people are um who have, I guess, knowledge that they can give to you in this field. So like clinicians and healthcare workers, especially people who will be using your device. Like you should define like a target population who is specifically going to be using your device and then interviewing those people so that they can give you insight on that. Because like as researchers, like as members of people who are attending these competitions, it's so easy to be like, oh well, we can make this decision for this design and it makes sense to us. But when you interview someone, they might be a bit confused about like why you added that like specific feature, if that like makes sense. So yeah, I think that is something that we would have done differently if we had more time. Obviously, it's very difficult to organize these interviews because people are busy. But yeah, just like reaching out to people. I think people are always willing to help and share their knowledge. So that's like the one advice that I would give.
Oh, okay, okay. Thank you.
Hmm.
And did you like divide your team into department like here in iGEM? How many people work on the outside, if I may know?
We didn't really have specific departments. It was kind of like wet lab, dry lab. Obviously, some people had like more, like for example, I was dry lab, but I didn't really know how to make like the website, so I focused more on like modeling and the other deliverables, like the presentation and the YouTube video. Um, but we had, I want to say we had like two main people who focused on the the LSI stuff, like the research behind that.
Okay. And do you know the people behind the maybe this year's iGEM from your uni?
No, I don't know anyone on the IGEM team. Yeah, sorry about that.
It's
I'm
okay.
sure they're all really nice, but yeah, after I'll be completely honest, after like the biomod competition, I mean, I kind of like stopped being involved like in the competition.
Hmm.
So yeah, I don't know who's on the iGEM team this year. I guess like if you want to like look at their Instagram, that's probably like the best way to find out what they're up to, or maybe they have a website as well. But yeah, sorry, I have no idea who is on the team this year.
Okay, maybe any of you guys want to ask? Okay,
Okay,
so
maybe you want to ask again. Sorry if I maybe missed part of your explanation earlier, but I want to ask, like, I noticed from the website that you presented before that your team also uh, discussed or noticed about the government regulatory considerations, but I want to ask, like, did you directly ever introduce the government stakeholders? Because actually, in iGEM, I've seen that some teams actually consult to the government institution, but did you do it in your biomod team project before?
I don't think we specifically introduced them. Are you talking about like the people that we interviewed?
Yeah, or only
Yeah.
based on, yeah.
No, and I don't think you normally do. I think you normally keep like the information like anonymized. So you can maybe like give a description of like who they are and what they do if they're like if they consented to providing that information. So you can say like, oh, like healthcare worker who works in like the ICU or something. But usually you don't introduce like the interviewers. It's more so for yourself to kind of guide like your project. But I don't in research projects, I don't think you normally introduce like who you interviewed, if that makes sense.
No, I'm sorry. What I meant was like, did you do interview with government people or
Oh,
only
I
based
see.
on the regulatory?
Oh, I see.
Yeah.
No, we didn't get a chance to. So, all the regulatory research we did was purely on literature. I think it was a bit tricky for us at least to find people who like worked in that specific field, like the government and like the regulatory department. Because I mean, they're like at a government level, they have like better things to do than to like interview students who are just like doing this for a competition. But I don't know, you might be able to find people. But yeah, we didn't get a chance to, unfortunately.
Okay. Thank you.
Yeah. I found our presentation from the biomod competition, so I'll share my screen. So this is honestly all we had for the ELSI stuff. It's only one slide. And so I think again, what I mentioned before, it's really important to try to keep things as simple as possible because these competitions you have a time limit and you have to go through everything. And so although ELSI is important, it's also really important to go through everything else. So any research that you do end up doing, I think it's better to include in the website rather than the presentation. So you can just give a very brief overview of like the categories or like the topics that you guys are addressing like we did here. So we talked about the respect for persons, the concern for welfare, and the justice in terms of ethical, legal, and social issues. But I wouldn't say don't go into very much depth during the presentation. So yeah, and I can also send you guys our presentation as well. But obviously I know the guidelines for biomod and iGEM are different, but hopefully it can still be even just a little bit helpful for you guys. Yeah.
All right, thank you, Durwyn.
Hmm.
Um, maybe because you said that you work on the dry lab,
Mm-hmm.
I also want to ask about the dry lab. Is
Mm-hmm.
it okay?
Yeah, I would say it was good. I think we accomplished a lot more in the dry lab versus the wet lab. Uh, it did get a bit complicated at times with like the modeling and stuff and like looking at the interaction between um like the proteins and like the biomarkers and then like the aptamers we were using. That did get a little bit complicated at times to like see like the actual interaction between it. But I would say it was good. I think yeah, I don't know if you have like more
Yeah.
questions on like the dry lab, but
Maybe is it possible to present first like what you did on the dry lab, and
yeah,
maybe
for sure.
I will know what to ask and what relates to
Yeah.
our project.
Okay, let me see here. So I'm just gonna use our presentation that we did for the competition.
Yes.
Okay. So computational results.
Yes.
Let's see here.
Is
So
it
yeah,
something?
we kind of had like a modeling process. Here, sorry, let me. Yeah, we kind of had a modeling process. So we modeled the enzyme, and then the aptamer and the target, and then molecular docking, which, if I'm not mistaken, is like the interaction between the two. Um, and that's like the reaction itself is what made like the colored line on our design, and then the
All right.
results. Yeah, and so it looks scary, but that's just like what it looks like. That's just like the model. And so the two enzymes that we were looking at were like basically what color we wanted the line to be. And as you can see here, like that's the software that we use. I'm not sure what you guys are using, but Chimera. It was hard to learn at first, but it was really helpful. And you can do a lot with it. And then we ended up choosing this enzyme just because it was much smaller. I don't know if you can see here. I can't zoom in, but there's like a little like blue thing here versus like this pink thing. As you can see, the pink enzyme was very large, and so it just like wasn't feasible for what we wanted to do. So we went with like the smaller size one just to avoid things like hindrance. Um, so yeah, after that we modeled the aptamer, and so these were the actual biomarkers that we were looking at. Um, and these were generated with these softwares. Sorry, it's been a while since I've done this. Um, yeah, and so we chose this biomarker just due to because it was simple and it was predictable. But again, that was like informed through like literature. And then molecular docking, as you can see, like these are like the interactions between like the enzyme and the biomarker.
I see. So
For
you're
these
trying
results,
to dock aptamer into protein, is that right?
yeah, essentially, yes. Unfortunately for these results, I am not able to tell you what is going on because I did not do these calculations or these like scores. Um, I can send you a presentation after, just so you can like read more about it. But yeah, I'm so sorry I can't be more helpful for this specifically. This was our team lead. She did all of these numbers. But essentially, these numbers like basically tell you like how good the reaction was. And so yeah, we did the results for all the different biomarkers. So we have like a confidence score, which like represents like how certain that you can be. As you can see, like closer to 1 means that you're more certain. But yeah, sorry I can't be more helpful for these numbers. But yeah, that's basically what we did for the dry lab. And then the dry lab, for, at least for Biomod, also included coding the website. Yeah.
Wow. Okay. Because I think we also do the similar things here, but our target is also the protein, right? So what differs, I think we will do the protein docking instead of protein with aptamer.
Hmm.
Okay. All right, Derwin. Thank you so much. Maybe um anyone guys want to ask? So you don't really do another competition again?
Probably not. I think I'm done.
Not not in the
It's a
future?
lot of work. It's hard work, and so I admire you guys because it's a lot of work, but it's really good. It's really good experience. I mean, you were part of Biomod, and you know the work that goes into it, and so I think
Hmm.
the experience that you get is what really matters.
Hmm.
And also just like meeting people. I'm sure you'll meet lots of great people at the iGEM competition. Um, yeah, I guess like my last thing I want to say is just like good luck. Like you guys have a very good like project, and I'm sure you guys will do amazing. When is the competition?
The final will be on November
November. Okay.
16th.
Okay,
Yeah.
so you guys have lots of time. Okay, that's good. That's good.
Yep.
So So
And maybe one last question, Derwin.
yeah,
Like
yeah.
you said earlier that you didn't do much with the web lab stuff, right?
Hmm.
Why did it happen? Like, is it because the facilities, or is it because the chemical reagents, or
No, it was nothing to do with like the materials itself. It was our fault. Like we were very unorganized, so we weren't able to like book um like facilities like the wet lab on our campus. We weren't able to book times to use it, and so we were kind of scrambling at the end. But in terms of like feasibility to test, like we would have been able to do it. Like we had a lot of things that we wanted to do in the wet lab, but we just
Mm,
ran out of time. So yeah, make sure you start early for that. Um, just because like we didn't like I was honestly I was in the wet lab
mm,
like twice, and that's like not enough. Like, you know, I'm not sure how much time you guys spend on like iGEM, but we wanted to be in the lab like at least 3 to 4 times a week. It just like didn't happen. So, oh well, you know, life happens and it's okay.
mm. Yeah. But did you have like advisors helping you with the lab stuff? Maybe some graduate students, or
Yeah, we did. We
mm,
did have some graduate students. We had like a lab technician who kind of oversaw everything we were doing.
mm,
Um, we had we had like a supervisor who was just like a professor who kind of helped inform our protocol, but a lot of the protocol was just developed through like our research. They weren't super like involved. So it's nice to kind of gain their input, but I think because
mm,
you guys know your project the best,
yep.
it's best if you guys develop like your own protocol and goals for the wet lab. Mhm.
Yep.
Yeah.
Okay. Well, yeah, we also plan to have maybe 3 until 4 times a week to do the lab stuff, but let's see. Finger crossed. I hope we can have much better management in
Yeah.
the lab project.
Yeah.
Yep. All right, Derwin. Thank you so much for your
Of
time.
course. Thank you for having me. I hope something I said was helpful. I don't know.
Yes, it is. It is. Thank you so much once again. Uh, I think I hope we don't disturb your holiday. I know. I
Oh,
think
no
you're
worries.
in Mexico right now, right?
Oh no,
Is it?
I'm not in Mexico. I was in Mexico 2 weeks ago.
Oh, 2 weeks ago.
I've been back home. I've been working. Today is Saturday. I'm just at home.
All right.
So yeah. Well, good luck, guys. You guys are gonna do amazing. Let's stay in touch. I'll ask you how the competition went. I'm excited for you guys. You guys are
Yes,
gonna do
you can always
a great
hit
job.
me in the DMs.
Yeah.
Thank you
You
so
guys are all
much.
you guys are all very smart and very bright people. I know you guys are gonna do amazing. So
Thank you. Thank
good luck.
you.
All
All
right.
right,
Well,
Yeah, thank you,
Darwin.
thank
Thank you so
you.
much.
Maybe lastly, can we do the recommendation?
Oh yeah.
recommendation.
Yes, yes.
Yeah, yeah, yeah.
Yeah, recommendations for what? Like the competition?
No, no, no.
I
Documentation
know.
for selfies, online selfies.
Oh, okay. Yeah,
We
yeah.
will screenshot the the meet. Okay.
Okay.
Can you do our post? I don't know if you still remember our post.
You want
This.
me to do your post?
Yeah.
Oh, okay.
You still remember it?
Yeah.
The SynBio post. All right. One, two, three. One, two, three. Okay. Thank you so much, Joanne.
First. Okay. Bye,
See
everyone.
you later. Bye
Thanks for
bye.
having me.
Thank you so much.
Nice day.
Kak,
Hello.
Kak jangan lupa di follow up itunya PPT-nya. Siapa tahu jadi kirim.
PPT. Oh iya ya. Oke.
Ya, ya.
Nanti aku DM. Dry lab bisa ketemu hari Senin nggak? Habis itu tuh, habis ketemu Pak Tunjung. Jadi kan jam 7 ya?
Sorry, tadi gimana Kak? Ketemu jam berapa?
Offline.
Offline Senin jam berapa?
Kita lanjutin MD kita.
Oke.
Jam berapa? Terserah kalian bisanya jam berapa.
Gimana, Fis? Aku Senin nggak ada apa-apa sih. Do I, wait, Senin ya?
Senin.
Bisa sih, aku bisa.
Oke. Kalian tanya-tanya dong kalau ada informal classes. Kemarin pernah tanya nggak Verlin yang sama dosennya Aska? Pada nanya-nanya nggak?
Jujur itu dosennya yang ada yang tanya sih, tapi dosennya lebih banyak presentasi.
Tanya-tanya dong kayak nggak usah yang wet lab atau dry lab atau yang creative media, yang human practices. Kalian buat networking gitu loh, kayak tanya aja IG-nya boleh follow nggak, atau LinkedIn-nya boleh connect nggak gitu loh.
Oh,
Nanti next sama Prof Rizal kapan?
Minggu depan hari Sabtu.
Minggu depan. Jam malam juga dong ya sama orang US.
Jam berapa, Shell?
Jam ini 8.
8?
Iya, 20.00.
Oh, jam berapa tuh di dia?
Jam 6 I guess. Soalnya katanya dia jam 7.30
Di
mau ngangkat
Arizona kan beliau.
anak-anaknya ke sekolah atau apa nggak ngerti.
Iya, jam 6 pagi di
Gile, rajin amat.
Oh ya Kak, aku mau tanya sama ada ini kita bisa kontak Kak Ilham tuh Kak Ilham nggak?
Nggak tahu.
Yang iJam 21 Ilham nggak sih namanya?
Oh iya iya. Oke, yang di BI ya sekarang ya. Bank Indonesia kan? Sekarang di Bank Indonesia.
Oh ya?
Iya.
Kalbio katanya, Kalbio.
Oh, Ilham 21 aja, tahu. Ya, ya, ya.
Bisa nggak? Kira-kira apa ya? Kakaknya di
Dia orang
bagian
wet
apa
lab.
gitu?
Dia orang
Oh,
wet lab jam 21.
oke.
Dia orang wet lab. Aku pernah Zoom juga tahun lalu kayaknya.
Oke, nanti aku coba chat.
Aku masih bingung ini sih sebetulnya yang kayak kita harus bilang Mas Soldi nggak ya di project kayak di judulnya. Kayak terlalu ambisius gak ya kalau bilang Mas Soldi? Apa kalau nggak ditaruh malah jadi nggak terlalu ini punya poin yang ada di society gitu kan. Waktu itu siapa sih yang present ya kayak harus disukain sama yang disukain sama apa sih yang disukain sama juri adalah yang masalah yang niche di community kita gitu kan.
Kak Novia. Iya,
Gak tau deh, lupa siapa.
iya.
Nah itu maksudnya kayak sebenarnya bisa aja kayak modelnya tuh nggak spesifik bakteri mesoldi, tapi pas presentasi mulainya kayak biasa tuh selalu mulainya orang-orang aja coba deh buka-buka. Jadi semua presentasi pemenang tuh bisa dicek di websitenya kayak semua terekam. Biasanya selalu pasti kayak nunjukin satu story gitu. Entah itu misalkan dia pas masih kecil, dia tentang kejadian di daerah dia, kayak gitu. Tapi di judulnya mungkin ini kali ya, detection bakteri aja gitu.
Kalau dari saran PI-nya bilang sebaiknya gimana?
Well, PI sih fleksibel sih, cuman I mean kalau mau bilang MASLD harus ada yang nunjukin dia betul-betul di MASLD gitu. I think ini sih targetnya harus cari lagi. Let me think about it deh, tapi nggak apa yang sekarang jalan terus aja.
Tapi kalau
Ada
misalnya
kenapa?
kalau bukan muscle D, tapi kan dari dry lab kan fokusnya ke studi muscle D.
Well, yang tadi aku bilang bisa jadi cerita di awal gitu.
Oh,
Sama, well kalau mau diperbesar lagi juga bisa menambah penyakit lain gitu. Maybe pakai study case gitu loh modelnya. Pinter-pinter menarasikannya aja sih.
iya iya.
Kemarin tier D ada nggak tier D?
Eh,
Halo?
Gimana?
Kemarin kita tuh mau nanya, kan yang salah satu kita pakai tuh Enterococcus faecalis. Itu nggak pernah sama sekali ada di biomarker yang kamu cari ya?
Nggak apa sih. Tapi sumpah yang kemarin tim tuh emang kayaknya oke banget deh. Yang itu doang yang aku cari.
Gimana?
Nggak cari yang itu. Terus yang jenis bakterium yang di 85 itu menurutku udah oke banget karena dia lebih banyaknya ditemuin di kulit tapi dia juga pemakan lemaknya
QT bacterium ya.
yang ditemuin di 85. Kak Terde yang yang OT baru udah di ini belum ya? Udah dicoba live belum? Yang OT baru. Maksudnya yang baru apa aja yang baru? Yang dua doang itu. Sorry, gimana? Ups, sorry. Gimana tadi Kak Terdi? Yang OTU 2 kan udah ku upload kemarin. Udah belum? Yang 13 sama 9 kan? Hah? Yang 13 sama 9 kan? Apa ada baru lagi? Iya, yang pokoknya yang 2 baru. Udah, tapi yang 9 nggak ada markernya di live say. Yang 9 nggak ada marker tuh berarti maksudnya gimana tuh? Ada deteksinya, tapi let me benar, aku coba tunjukin aku baru PCOE buat yang pakai algoritma aku sendiri. Nah, algoritma Tirdi. Ya kak. Tes. Ya. Oh, iya.
Nggak kedengeran nggak? Patah-patah.
Aku pakai algoritma aku sendiri, aku coba kan. Terus aku sasiin PCOE. Aku kirim di grup deh. Grup?
Oke.
Itu hasilnya better daripada live sih. Tapi aku masih coba di 85 doang. Di 85, 851 itu. Oke.
Tapi kalau sebelumnya alasan buat milih LSI itu apa ya Kak? Buat metodenya.
Oh, kan dari Zio.
Oh.
Dia memang dipakai di paper untuk ini sih selalu nyari pembeda. Jadi dikasih value positif sama negatif buat cari yang benar-benar beda gitu antara patient.
I see.
Yang kemarin apa aja, Tir? Biomarker nomor satunya?
Yang Mas ku cari itu yang cuti kirim yang 85 doang.
Kalau yang ini, kalau yang baik, bakteri baik.
Oh, banyak beda-beda. Bentar.
Beda-beda. Nomor satu apa?
Bentar.
FL fatty liver kan?
By the way, yang Inca sama apa tuh? Culture udah di ini, Shell. Dijawab nggak?
Yang sebentar aku coba cek lagi. Sempat ada yang ngejawab gak ada gitu, tapi aku lupa dari apa. Bentar.
Gimana, Tir? Apa yang bakteri baik?
Bentar.
Kultur collection aja nggak ada. Terus kalau misalnya yang Brin ternyata udah dicat sama yang Kafret itu. Terus kalau misalnya yang satunya lagi itu yang harus nunggu sampai 3 bulan. Yang dari si genetika
Itu
science.
dari ATCC ya?
Iya, ATCC genetika science. 2 bulan deh.
Katanya kalau sebut nama Shelfani jadi cuman seminggu.
Iya betul Kak, oh my god, aku nggak kepikiran, keren banget. Sebentar ya Kak, aku chat. Haha. Maaf bercanda.
And
Kontrol udah
apa? Apa, Tir?
45.
Hah?
Tinnitus.
Apa-apa? Patah-patah, oi.
Pektin.
Hah?
Bentar.
Patah-patah. Pectinatus. Pectinatus. Selain itu, ada nggak yang lebih common? Subdograd. Kayak lactobacillus gitu ada nggak, Tir? Bacillus from Bacillus. Bye bye Miss American Pie. Trust my shit, tell you. That's right. I'm good, boy, who can tell skin and say this will be the day that I die. This will be the day that I die. Pectinatus. Kalau yang sehat, monoglobus. Berarti LDA score-nya harusnya sih minus ya, Tir, kalau sehat ya. Ada di 8. Oh, enterococcus.
Hanif. Kadina.
Coba deh itu Lin coba tanya yang aku suruh kemarin, tanya-tanya IJM Indonesia lain, kayak mereka udah nyampe mana sih?
Ya itu Shell lagi chat. Aku
Yang ITB UI ramai banget anjir, 30 orang ada kali.
emang iya?
Lihat
Apa?
aja ini.
Enggak, aku pikir kayak orang yang sama di divisi yang berbeda gitu.
Lihat aja ininya IG.
Siapa tahu mukanya sama-sama ya teman.
Ketuanya
jujur
yang
antara
kita
dilihat
ketemu di
beda-beda
bios
mukanya
kemarin.
kan.
Iya, Daniel.
Soalnya itu gabung 2 univ kan. Jadi harusnya itu yang satu handle yang ini, satu yang handle ITB gitu nggak sih? Harusnya aman aja.
Angkatan berapa deh ketuanya tuh? 25 nggak sih? 24 ya?
24.
Gak ada tulisan angkatan.
Enggak kok, ini ada Maria nih. Maria yang waktu itu aku kenal. Enggak tahu ya Kak Maria atau apa. Dia di human practice, dry lab, wet lab. Wow.
Masa nggak ada enterococcus sama sekali ya dry lab ya di ini, di penelitian kita yang nyari biomarker. Padahal dia harusnya. Oh, apa itu tuh fokusnya ada nggak ada ya, Tir? Jadi nggak mempertimbangkan banyak kenaikan atau enggaknya.
Mempertimbangkan kok yang itu, yang apa?
Left sih.
Rekur, yang
Left sih.
algoritma seperti itu doang.
Gimana?
Yang left saya mempertimbangkan, terus tapi yang algoritma aku full pertimbangan itu doang. Banyak atau tidak sama prevalensi. Ntar aku kirim deh.
Pak Prof Rizal Sabtu depan ya?
Iya.
Alright.
Kalau aku lihat di rosternya sekarang mereka 20 orang sih.
20. Ajak Zoom bareng aja coba. Idenya udah tahu belum sih mereka apa?
Belum dibahas. Tapi UGM belum daftar ya, apa gimana deh?
Gak tau, di website IJM aja. Di website IJM udah belum?
Not yet.
Apa nggak ikut tahun ini?
Nggak mungkin gak sih?
Kenapa nggak mungkin?
Karena dia udah prepare dari tahun sebelumnya.
Siapa tahu fumble. EBP.
Yang udah ada topik sih IJM ITB ini. Gak apa-apa, kita selalu.
Algoritma tier D. Tier D slow. Gila, udah belum S1 udah menciptakan hukum sendiri, cuy. Tier D laws of statistic.
Kak udah tahu nggak yang IJM ITB?
Kenapa?
Topiknya.
ITB UI.
Nggak yang ITB Solo.
Oh, ada gitu ya? ITB, ITB
Iya.
2 ya? Terus
Iya,
nggak ribet,
Joy.
terus nggak ribet tuh kayak dua tim. Oh, lu nggak ikut kita.
Dia topiknya soal bioreactor.
Hmm. Kopi-kopi
Extraction.
gitu nggak sih?
Iya benar. Coffee extraction. Beda banget.
Yes.
Ini Hanif sama Kak Dina udah bobo ya.
Shell, kalau enterococcus tuh nggak ada sama sekali. Nggak ada sama sekali. Maksudnya ada yang ready nggak?
Oh, kulturnya.
Mm-mm.
Palingan yang 2 bulan itu. Yang dari UGM nggak ada. Yang Brin udah di chat ke Frederick kan waktu itu. Ternyata. Wow.
Iya, tapi kayaknya inasisi sama atisisi nggak sama. Jadi aku
Gimana kalau gini, Shell?
Apa.
Kamu malam-malam datang ke INACC, kamu lempar tali, terus
Iya. Terus.
Menyelinap, ambil.
Ah, nggak asik kalau menyelinap, Fer.
oh langsung ya.
Bagus.
Jadi naik
Aku maunya
mobil
itu tuh talinya langsung aku tangkep kulturnya gitu loh, Kak. Dari jendela kayak langsung sat gitu, langsung muncul. Lalu kita tarik, lalu dibawa ke Malang, baru kita nge-lab. Gimana, Kak?
Setuju. Itu
Iya kan? Itu Kakak juga mau balik Jakarta buat itu kan?
loh,
Jakarta dulu, baru habis itu ke INAICC-nya buat
langsung
ambil
tabrak
kulturnya
pakai
kan?
bis.
Duh,
Terus nanti LC kita bilang aja
apa-apa.
kriminalisasi.
Ya udah. Semakin mahal
Sama
semakin
ini Phaeasium, Enterococcus Phaeasium kalau ada.
Kenapa mau nanya lagi itu? Apa-apa?
Enterococcus Phaeasium. Soalnya kayak aku
Sama-sama
merasa
enterococcus.
ya gimana kalau kita bilangnya human gut microbiome aja. Story-nya tetap ke
Muscle D.
iya tapi jangan sebut di judul, tapi
Iya.
bilangnya gimana kita detect human microbiome punya bakteri. Nah, targetnya
Lactobacillus.
itu ini aja yang pasti ada di gut microbiome. Doesn't need to be specific to muscle D. Misal Enterococcus. Tapi Enterococcus ini kita coba di beberapa surface proteinnya karena kalau aku baca selain EBP ada ESP, ada ACM, SCM, ACE. Gitu kayak bisa dicoba kira-kira berhasil nggak? Gimana? Perbedaan. Enterococcusnya sama, tapi maksudnya coba surface protein yang berbeda-beda. Enggak sih, kayaknya strain satu aja sih. Kayaknya malah memperlebar ininya. Sama misalkan satu lagi tuh yang paling basic kayak lactobacillus or bacillus yang ada di permukaan yang non patogenik gitu. Jadi nanti penelitiannya TIRDI tetap dipakai sebagai intro gitu loh kayak ini semua tuh disebabkan oleh biomarker spesifik. Kita coba menangani itu, tapi di wet lab-nya ditranslasi dari coba yang paling common dulu gitu, yang udah well characterized. Oke nggak sih kalau narasinya gitu? Kayak tetap jadi tetap linear gitu loh. Coba deh bantu cari kira-kira kalau yang paling common kan yang ada di makanan ya. Maksudnya pasti ada kulturnya di Indonesia. Lactobacillus, Streptococcus. Di yogurt apa lagi Len? Di yogurt.
Lactobacillus.
Lactobacillus. Maksudnya pakai yang pasti ada nggak sih? Di yogurt kan pasti ada. Di yogurt pasti ada. Maksudnya di nggak mesti inden ke Amerika lagi. Maybe di lab sini juga masih ada gitu. Aku sih mempertimbangkan itunya. Coba ya. Nanti kita cari-cari lagi. Sama kita targetnya tetap ke gut microbiome. That means kayaknya si Listeria and Staphylococcus aureus nggak masuk ke ini deh. Nggak masuk ke narasi kita. Jadi kita pakai yang memang ada di human guts aja gitu. Kenapa Nafis ngezoom gitu, Fis?
Kan dia shock.
Kocak banget. Tapi, kok aku enggak ya? Bukannya dia nyesuaiin badannya?
Nafis dari tadi ngezoom.
Dari tadi banget nih.
Emang.
Dia bukannya kalau aku minggir jadi tetap ke tengah ya? Boleh lagi. Tolong wet lab gimana?